Gravity. Newton knew that gravity is a force that attracts objects to each other, and his laws predicted the strength of this force with fantastic precision. But how does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. And Newton's laws provided no explanation.
Einstein found that no Band-Aid patches would fix Newtonian gravity. He had to invent a mechanism for it. He had to understand it.
After puzzling over this problem for more than 10 years, Einstein reached a startling conclusion. The secret to gravity lay in the nature of space-time. It was even more flexible than he had previously realized. It could stretch like an actual fabric. This was a truly radical break from Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
With Einstein, space became not only real, but flexible. So suddenly space had properties, suddenly space had curvature, suddenly space had a flexible kind of geometry, almost like a rubber sheet.